Okay, so when the terms of a geometric sequence are added, the result is known as a geometric series. For example, the geometric sequence 2, 4, 8, 16, and the geometric series 2 plus 4 plus 8 plus forever there, like that. Okay, so it says the formulas for the sum of a geometric series. This is just deriving the formula. You would never have to do this on your own. This is just giving us some inspiration as to how it's developed. So here's the sum formula for these terms. So, you start at A, the next term's AR, the term after that's AR squared, right? That's just how you get the next term. And we're going to add up in between. All the way until you get to, 1 less than the total number of terms. So then they just do something kind of clever in the next line. They multiply by R. And this is just some clever, algebraic move. And then they subtract this second line from the first line. And what ends up happening is, I'll show you here. And again, this is not just too important. It's just sort of some inspiration as to where this formula came from. So when you subtract, these guys are starting to disappear. Okay, and then that pattern would hold, and you'd just be left with A and ARN. Okay, and then they do a little factoring right here. They factor SN out, and then they divide by this, and they develop the formula. So this is the formula. Like, you don't need to know how it's developed, but it's just pretty clever there. So what do we need to find the sum of n terms in a geometric sequence? What do we need? You need your first term, you need your common ratio, and you need the number of terms. Okay, so you need the first, you need the ratio, and you need the number of. And then you'll be okay. And you'll be able to use the sum formula. Okay, so I would go with this one here. Okay, and then they're going to give you a variation on this formula after this. Okay. What's important here, though, is if any three of these values are known, the fourth can be determined. So they might set you up, like they might tell you the sum, and they say, well, what's the first term? And you'd have to do a little algebra to find it. Okay. Okay, so then it says, however, when the number of terms is not known, so you don't know n, but the last term is known, another formula for the sum of n terms of a geometric series can be formed by replacing ARn minus 1 by Tn. So again, they just do some little clever algebra, which we'll actually show down here, to get this other formula here. So for this formula down here, you need R, the ratio, Tn, the last term. And A, the first term. Okay, so class example 1 is just going to be like sort of like the proof of this second formula, so it's not too important. We can do it quickly. It's not that important. So you start with this sum formula that was developed at the top of the page. You start there. Okay, and then it's like you have to have some inspiration for this. You multiply A in. So you're just distributing A. And then like this next step, after you distribute, like you got to be super clever to be able to do this. Like if you're just doing this like on your own to try to develop formulas, if that's like a thing of yours. So this term ARN, is the same as your R value multiplied by the previous term. And you're still going to subtract A all over R minus 1. So the only thing that changed was this. It became this. And like that's a pretty clever algebraic move. And like why would I even want to do that? Well, the reason is because this AR to the n minus 1 is actually the formula for a geometric sequence. So this thing highlighted in blue is actually, that's your formula for Tn, right? So now we can sub that in. R Tn minus A over R minus 1. So again, this is like some higher level mathematics that I would not stress out about. Do not stress out about class example 1. It's just a developing formula. So not high school test worthy. Your test questions will look way more like these. Okay, these are what you need to study. So let's take a look at the first question, class example 2. It says determine the sum of the first 15 terms. So what are you looking for? S15. That's the goal. Okay. So what do you know from this sequence? Good. A is -5 and R. This is always findable. R. Okay. Otherwise, like, there's no point. You have to have the R value. So you can see that the sequence is alternating in sign. That will only happen if the R value is negative. And then 5 to 10 is multiplying by 2. Good. So you know the A value, you know the R value. And this 15 is the N value. So you have A, R, and N. And I think that's what I told you need for the first formula. So I'm just going to jot down the first formula for you so you don't have to look back. A Rn minus 1 in a bracket all over R minus 1. Okay? So that's just the formula. And this is what we know. Okay? So just zoom out a bit so you can see it all. We know that junk. This is our formula. Now we just plug and play. Okay? Let's start with the left. What can you do to the left? Other than switch the n to a 15, there's nothing you can do. Now let's take a look at the right. Starting on the numerator, we have -5 outside of a bracket. Now inside the bracket, you have R to the n. So what's R? So we write -2 in a bracket to the n. Oh wait, we know n, right? So there's no point in putting n. Let's put 15 minus 1, and then we close that outside bracket. All over -2 in a bracket minus 1. Now, if you are organized like me, you will have success on your calculator. If you are unorganized, you will have issues with negatives, and it's going to piss you off, I promise. Okay, watch common mistake. Whoops. What's the answer to this problem? -3 squared. 9. Now watch this. Again, -3 squared. What did the calculator just do? It screwed up. The calculator screwed up because you didn't put in brackets. What this calculator does is it does BEDMAS. It will do your exponent first, and then what it does takes your 3 squared and multiplies it by -1. Okay, so my recommendation is to be organized with brackets so that the TI doesn't mess your life up. Okay? Somebody's going to dictate this to me as I put it in the calculator, okay? Someone's going to dictate it to me. I got negative 5. Then it's a left bracket, another bracket, negative 2, power 15, and then we will minus 1, and then close the bracket, right? Divided by. Now we got to be even more careful. I would do a double bracket here. So you have a bracket for the denominator, and now a bracket for negative 2 minus 1, and then close that bracket. And then I get something that looks reasonable. Well, I mean, there's no decimal and stuff, right? So it looks like I won. Okay. Okay. So let me throw back the screen on, and let's see if there's some notes I can give you for the calculator. Okay. In my blue pen, the only thing I added was this in the calculator. Just an extra set of brackets for this in the calculator. In the calculator, I always, no matter what, if I'm doing a ratio in the calculator, I'll always have a bracket for the numerator slash a bracket for the denominator. Now I put whatever crap is up here in there. So all this crap goes in there, and then this junk here goes in there. Okay? So structure is key. All right, let's go to the next one. Let's contrast the first example to the next example. Okay? So what's the difference between 3 and 2 here? Okay, so we have the last term. We have the last, but here we don't, right? So here our n is a question mark, but here n is n we know, right? Could you find n in class example 3 and then use the formula we just did? We could do that. But there's a faster way because we know the last term, and that's just going to be the second formula. I'll just jot down the second formula for you. Okay, because we know R. What's R? Good, negative 3, because it's alternating signs and being multiplied by 3. A is 4. And we know the last term is negative 8,748. Okay. An alternative strategy would be to find the number of terms using the original Tn formula, AR to the n minus 1, and then using this formula up above. But that's too much work when we have this one for free. So R negative 3, Tn negative 8,748. Notice the brackets. Minus 4. So basically, as a rule of thumb in mathematics, when you are substituting in numerical values into letters, I just wrap a bracket around it. And then I'm careful. So R value, bracket, negative 3, subtracting 1. Now, this is what I find, especially sometimes at East Glen. I'm not sure why, but students sometimes have difficulty with the calculator, and it sucks because you guys do the right math and then you don't know how to use the calculator. So it's sort of sad. Okay, so this is what I'll remind you of. You want a bracket, a divide, a bracket. So we're going to put stuff in there, and we're going to put stuff in there. Can you remember that structure? Numerator divided by denominator, okay? So, what's the numerator? Yeah, yell it for me. Negative 3. Yeah. Minus 4. Was 4 in a bracket? Okay, so is that my numerator? This bracket starts the numerator. This bracket ends the numerator. And is this what I had written down? Now we can hit divide then. And now we'll put the denominator in. So that bracket starts the denominator. And like it was negative 3 minus 1. End bracket. 6, 5, 60 negative. Okay, so you can be smart and wise with your math on paper. Translate it smart and wise to this device. Okay, then you're not worrying about mathematical like miscalculation because you type stuff in wrong. Okay, so negative 6, 5, 60. All right. Now, class example 4, it says the sum of a certain number of terms is blah. Okay, so certain number of terms, that means we don't know n. Okay, but it says the sum is this. Okay, let's take a look at our sequence. Can we figure out what r is? This is always doable. Negative 4. Okay, so we've used this. Check that piece of information off. We've got r. Check that off. And then it says what is the last term? So tn question mark. Oh, good. Thank you. Who said that? Keep me on my toes. Good. A is negative 2. You always need A. All right. So do I use the first formula on that previous page or the second? Because the second one has Tn as an option, right? So let's just jot that formula down. Sn equals Rtn minus A over R minus 1. Now we substitute in what we know. And then we're going to have to solve for Tn. Oh, son of a gun. Let me just pause. I feel bad. More. Okay. Okay, so let's solve for our missing term. Substituting in what we know. So Sn is minus 104,858. And you can see that you have like a number equals like a fraction. Some people will put numbers over 1 to help them. Now let's substitute in on the right side. So r is negative 4. We don't know what Tn is. I'm just going to put that in a different color because it's our goal. And then we're going to go minus A, which is negative 2. And if you do not use brackets for substitution, little details like subtracting a negative 2 are going to mess your life up because you're not going to realize that minus negative 2 is actually plus 2, okay, when you get to your algebra. All over r minus 1. So negative 4 minus 1. All right, so we got this here. Come on. I need to copy this and paste it somewhere else so there's more room. And I don't think it's going to work. Okay. So let's take a look at this. I'll use my pointer. We want this Tn, correct? So we got to get rid of this. We got to get rid of this. And we got to get rid of this. Okay? So let's clean this up as best as possible. Let's move this up here. Negative 104,858 over 1, that's just to help us, equals negative 4tn plus 2 over negative 4 subtract 1, negative 5. Any questions on that cleanup? That's all that was. This is a little cleanup. Now at this point, you need to be able to have success in this course, understand the order of solving. So like this negative 4, getting rid of that is the very last thing we do, because it's straight attached to this. Okay, and we can't subtract 2 right away onto the other side, because this is actually 2 divided by negative 5. So the easiest course is to get rid of this negative 5 first by timesing by negative 5 on both sides, which basically amounts to a cross multiplication. This guy on the bottom right goes where? Top left. In fraction equals fraction situations, you cross multiply. I think most of you guys know that. But easy way to think about it is opposites. Bottom right goes to top left. Top right goes to bottom left. You just have to know the cross, and that's it. Okay? So I just need to take these two numbers and multiply them. What are they? Someone do that for me. Positive 5, 2, 524,290 equals negative 4 Tn plus 2. Let me just zoom that in for you guys. So I'm still searching for Tn. I need to isolate it. At this point, it should be more familiar, like junior high styles, how to get the 2 out of there. So minus 2, minus 2. We have 52, 4, 2, 8. 8 equals negative 4 Tn. And now I'm happy because I know if it ends in 8, it's going to divide by 4. Here we'll divide by a negative 4. Dividing by negative 4. Why do we divide by negative 4? Yeah, this has to be identical, right? Identical so that you get, when it divides, you get 1 Tn. That's what you want on the right? Positive 1 Tn. So you have to divide by the identical coefficient on both sides. So here you have a positive dividing a negative, and this comes out to what? Negative 131,072. Thank you for that. So there's your first term, or pardon me, there's your last term in this sequence. So I'll put that there for you, last term, if the sum was this 104,858. Pardon, zoom in again? Sure. So as you're getting that copy down, you can look ahead to question 5 and see what's missing there. What's missing in number 5? All right. You got that, Carl? No worries. Okay, let's take a look at class example 5. And again, a good strategy in your math and science courses, as you read, jot stuff down. Okay, so geometric. Okay, I know which formulas I'm using. Okay, fifth term. Okay, so I can jot that down. What does that look like? In symbols, what would you write? T5 equals your 1024. And then we have this common ratio, so I can go, okay, well, R is 4. And then it says find the sum of the first 7. So I need S7, question mark. And then now there's no confusion. I know exactly what I need to do, just whether I can execute it or not, okay? Now in the first page I told you that for both formulas you need A, and we don't have that. So how in the heck are we going to find A? We're not. No. No, that's for arithmetic, I think, maybe. Oh, I don't know where you're going with that, but maybe you're on the right track. I would just say, like, if you're doing geometric series, don't forget that it all relies on geometric sequence, right? So just use the sequence formula. So what's the formula for T5? A, R, n minus 1. So what would it be? A, 4, and then n minus 1, so 5 minus 1. And that's equal to 1024. So you have you have A, yeah, you can't jump into arithmetic stuff if it tells you right off the hop it's geometric, right? Okay, so what's 4 to the 4? 256. And over here is 1024. So something times 256 is 1024. Just divide it out. 1024 divided by 256. And you get A is, so okay, so that's a lot of 4s. A is 4 and R is 4. That's just random. That didn't happen. That you know, the fact that they're both 4s, that's just random. Coincidence, I guess. So now we can find S7 because we know N, right? We know A and we know R. You know NAR. You know NAR. So we're using the first formula. Sn equals A to the multiplied by R to the n minus 1 all over R minus 1. Plugging in what we know, we found out that A was 4. R is also 4 to the power 7 terms, right? First 7, we're finding S7 minus 1 all over 4 minus 1. Any issues with that? Okay, and I'll just do this one like if I had a scientific calculator and I was just trying to be careful. Maybe I don't have a Texas Instruments on the day of the test. What would I do? Well, I would just follow order of operations. So what do I do first here? Get this done first because it's in this bracket, right? So go 4 to the 7, 4 to the power 7. I got a big number, and then subtract 1. So 16,383. All over. And then because this bottom thing's in a bracket, I can do that as well. That's just a 3. So 16,383 times a 4, divide a 3. I got 21,844. Okay. So again, you don't have to type everything into your calculator and on your Texas Instruments, but you could. You can also just do it step by step like I've done here. Okay, class example 6. What if we don't know n? Determining the number of terms in a geometric series. So I guess this would be if you didn't know how many terms there are. So n question mark. Okay, so they've given us the sum of n terms. So we just don't know how many terms there are. So Sn is 16,400. This is all we know from that statement. But from the sequence, you can get R, which is good, and A being 5. So again, if you look at the very first thing we looked at, if any three of these values are known, the fourth can be determined. So we have Sn and then nar. Right now we have Sn, A, and R. So do we have three of the four? Okay. Now in math, if your unknown is in the exponent, you need this thing called logarithm, which isn't taught till the 30 level math. So you need to use your graphing calculator as a tool, technology, or there's this strategy with algebra called the common base, which only works out if it's nice numbers, which usually should work out with these. Okay, so let's plunk into our formula. Sn equals, keep forgetting this formula, A r to the n minus 1 over r minus 1. Okay, let's plunk in what we know. 16,400 equals A being 5, r being 3. 3 to the n minus 1. And you notice I didn't put a bracket in there. You can get away with it if there's no negatives. If it's positive, you can get away with it. And r being 3, so 3 minus 1. So just plug into the formula. Boom. Okay. Look at all the stuff in the way. Okay? It's kind of like when your brothers and sisters are like in your face. You want to get them out of your face. You got to get rid of this 5. You got to get rid of this minus 1. And you got to get rid of this 3 minus 1. Okay? So what did I do last time we were in this situation? I crossed, right? I cross multiplied. Remember that? Okay. Let's just clean this up first. Left side 16.4. Right side 5, 3n minus 1. And what's 3 take away 1 in the bottom there? 2. Okay, so what you really see on the right side is this. 5 halves, 3 to the n minus 1. This pen sucks. Can people see this? 5 halves, 3 to the n minus 1. So this 5 halves is like the coefficient. What's the opposite of 5 halves? Amen. Okay, so what's the opposite of 5 halves? 2/5. Okay? If you look at the cross action, 5 goes down and 2 goes up. Okay? So you take 16.4 times 2 divide 5, you get 6560. So is the 3 to the n isolated yet? What do you got to get rid of? Okay, plus 1, that's easy. 6, 5, 6, 1 equals 3 to the n. This up here says common base. So the base is, what's the base? The base is just 3, not the n. The base is 3. So now I need to write 6561 with a base of 3. You can guess and check on your calculator. Okay, so you can guess and check with your calculator. So do like 3 to the power 5. Oh, it's too small. 3 to the power 6, too small. 3 to the power, is it 8? Boom. So I can change 6561 to 3 to the 8. So logically, now that you can say that 8 equals n. So I'll zoom out so you guys can see the whole deal. Okay, so a lot going on. And the 20-1 student should be able to do this kind of algebra and then have the knowledge that if the power is the unknown, I gotta either do common base or graphing calculator. And that's what this book is doing for you. It's setting up both. Okay? Okay, so how to do the graphing calculator. And this is actually kind of like a nice little cheat for people who are kind of still struggling with algebra. So here we have the equation that we started with. Okay, so the left-hand side, all this stuff goes into y1, and the right-hand side goes into y2. All right, so what was the number? 16400? Okay, and the right side had this, I think it was a 5, a bracket, 3 to the power, and we'll use x minus 1, all divided by 2. All right. Now before I hit graph, because if you just hit graph right away, you're going to have to wait 10 seconds for this thing to load and you're going to be upset. The number that stands alone, this 16400, is going to shoot across the screen. You need to be able to see that. So in the window, your Y maximum has to be able to see that. Let's just go to 20,000. Now for sure I'll be able to see it. Now, do you think it'll take 160 jumps? Well, you know the answer is 8. So your standard window will look like minus 10 to 10. That's what your standard window will look like if you haven't been messing with your calculator. Now again, do we need negatives in there? Because we're doing counting, right? First term, second term. So you never have to have negative x. So starting at 0 is fine. Let's graph. There's that big number cutting across. And then here's this function sort of finding it. Boom. There it is. Second, trace, 5, bang, bang, bang. 3 times you press enter. And you get that x is 8. Okay, so you need a Texas Instruments calculator to be successful in Math 20-1. I only have 3 to borrow. So if I'm out and you don't have one, you might have to talk to another teacher to help you. What time's class over? Okay, because this next question is challenging. If you guys are too tired. Oh, this is a very, very important question. Do you guys want to wait until tomorrow? Because that way I won't start the new unit on Thursday. Okay, so that means we'll finish up this lesson tomorrow. Now if we look ahead, after this lesson is after this lesson is lesson 8. So this would be like Tuesday, Wednesday. Okay. And then lesson 9 is the practice test. So we'll do this Thursday. You'll have a whole block to work. And then your exam will be on Friday. Okay? And the exam has been written here for quite a while. This is Friday. This Friday. Okay? Yep. So for the homework today, I'll just make sure that we don't do the stuff that is the stuff that I haven't gone over yet. And if you've been handing in your quizzes because you've been away, they go in the cage here. Or if you've been if you registered late or whatever. Okay, so I think we're on page 67 for your homework. Okay, so number 1 for sure. Number 2 for sure. Number 3 for sure. Number 4 for sure. And 5. I think that might be a good spot to stop. 1 to 5. We'll go 1 to 5 with 6 as challenge. 6 more of a word problem. Okay, so at least 1 to 5. And then challenge yourself with 6. And we'll stop there for homework. We'll pick it up. We'll pick up this unit or this lesson tomorrow.